And finally, the most important tolerance is profile of a surface. This is used in body panels a lot because it's a visual aspect. All body panels have visual aspects, and a very tight profile are generally used in the outside or the fascia of the car, or on the outside of the tailgate of the car. So what profile means is that if I have a part that is fixed to my A and B datum, let's say in this case, I only want to constrain 5 degrees of freedom. That's why I don't have a tertiary datum. Okay, I don't have anything called out as C over here. Let's say I have some weird part and I just need to constrain A and B surfaces. It means that this part can come outside the screen, it can go inside the screen perfectly, okay, because I have not constrained the third surface. So 5 degrees of freedom constraint, but one translation is not constrained. That is, it can slide outside the screen, it can slide inside the screen, but it has a nice wave to it over here like this. And because of visual aspects, I have to control this wave over here. So in general, what the supplier can do is he can just make a part something like this and give it to me. But I don't want it to be like this. I want the surface to locate in exactly the nominal condition or in the CAD condition. So what I do is I will use a feature control frame, put a profile symbol over here. This is the tolerance zone. Again, should I put a phi over here? Is it a mistake? It's not a mistake. We don't need to put a phi over here because this is not a pin or a hole. Okay, it's just a surface. I don't need to put a phi over here. What it means is that it tells the manufacturer, hey buddy, make sure that you create 2 planes, one this way and another this way, and make sure this surface would lie between these 2 planes whose thickness is 0.03 millimeter. So the surface, let me change the color. So the surface can lie something like this, and it's perfectly fine by me. Okay, as long as it's between the range of 0.03 millimeter. So now I'm pretty sure you must have the question. So what's the difference between flatness and profile? Why do I have 2 different callouts for flatness and the profile? Again, flatness is a local phenomena. It does not control the location of the surface. So let's assume I do not have a profile over here. Oops, let me change the color. Let's say I only have a flatness over here of 0.03 millimeter. So what it would do is that the supplier does not get any idea of the location of this surface. On a very bad day, what he would do is, he will simply create a surface like this. And if I have only called out 0.3 millimeter, he will put 2 surfaces over here like this. And as long as this surface lie between the thickness of this 0.03 millimeter tolerance, he will say, okay, the part is good to go. But do I want the surface over here? No, I want the surface to be located over here this way. So profile controls the location of the surface. Flatness does not control the location. The location of the surface can be anywhere. It just controls the waviness of the surface. I hope that's clear. This was pretty confusing to me when I started out, but as you start working, get more experience, you kind of understand the subtle differences between these different types of tolerances. So for a machining tolerance, again, you can have anything between 0.5 to 1 is perfectly okay. And the supplier should be able to make any part, a machine part between 0.5 to 1. If you go tighter, 0.1, then he will just add cost to it. So up till now, we went through feature control frame, we went through datums, we went through 4 different types of tolerances, just the basic. Flatness controls the waviness, perpendicularity controls the perpendicularity, Position controls the position of the feature, and finally the profile controls the shape of the surface and also the location of the surface. And now we are going to use all these concepts that we learned right now in the last 30 minutes in an actual example.